with you, my dear students. So let's move forward and study the activity for this. We want to study about ferrous sulfate, and you can see that these ferrous sulfate crystals are green in color. See, I have taken this green colored ferrous sulfate crystals outside in a watch glass. This is what it is known as the watch glass. So we are going to take these crystals into the test tube now. See, I am adding the crystals, green color crystals in a particular test tube. You can see it easily. Now I am going to heat these crystals on the gas cylinder, my dear student. You can see that I have I hold this test tube with the device called test tube holder. And you can see I am going to heat it now.
क्या हम हॉस्टल में जा रहे हैं ठीक ठीक यहाँ क्यों रख रहे हैं
So now you can see that the crystals are being heated. We are heating these crystals. See, this is the potassium dichromate paper. That is what I am going to put on the face of the test tube, which gives us the idea that whether these gases produced are acidic or not. You can see I have you can see, my dear students, that the paper changes its color. It changes from the yellow to the orange red color. The color change is taking place because these gases which are coming out due to the decomposition of iron to sulfate or ferrous sulfate, they are generally acidic in nature, and this due to this acidic in nature, they turns the yellow paper into the orange paper, or you can see the yellow chromate paper into the orange dichromate paper. So it is the gas that, or it is, they are the gases which makes this paper to turn its color. So now, my dear students, you can see on your screen we have written the what can you see on your screen, my dear students? Dear students, can you see the decomposition of FeSO4 equation written on your screen?
Yes, sir.
Yes, sir.
Yes,
So
sir.
you have seen, my dear student, that initially we have taken the green colored crystal of FeSO4. This green colored crystals of FeSO4 turns into yellowish white Fe2O3 crystals, and these are the gases which are produced. These gases which are produced, these gases generally turns the yellow chromate paper to orange, and on the basis of that we can say that these gases which are produced, they were acidic in nature. So my dear students, on the basis of this we can understand how this decomposition of ferrous sulfate takes place, and this decomposition of ferrous sulfate is is because of the heat, and that is why it is known as the thermal decomposition. In the decomposition of ferrous sulfate, my dear students, the substance which is produced is yellowish white in color. That is your iron 2 oxide. You can even write the name for this. This is your iron 3 oxide, which is also known as ferric oxide. And my dear students, apart from that, we have the two gases formed, sulfur dioxide and sulfur trioxide, and both these gases are absolutely acidic in nature, and that acidic nature is being proved by the color change into the chromate paper. This chromate paper changes from the yellow color to the orange or orange red color. Now अगर बच्चों कुछ समझ में नहीं आए तो आप मुझसे पूछ सकते हैं और we can move forward. Do you understand this, my dear student?
Yes, sir.
All of you can reply, and if you do not understand, you can ask something if you do not understand. Let's move forward, my dear students, and let us study about the new type of decomposition. So in the decomposition itself, dear students, now let's look into in just the decomposition itself. Let us study about the electrical decomposition. Electrical decomposition. The previous decomposition that we have studied was the thermal decomposition. Now we want to study about the electrical decomposition. Why this decomposition are different? Because this is the electrical decomposition, that is the decomposition due to passage of electricity. This decomposition is due to the passage of electricity, my dear students. So when the electricity is passed, let me tell you one interesting thing, and that you already have been studied, or this is just a revision. So when the electricity is passed through acidified water. Please remember that the water should be acidified water at anode, or we can say that at positive electrode, we get oxygen gas, and my dear students, at cathode, which is your negative electrode, we get hydrogen gas. Now, my dear students, it's interesting to note this, but there are few things which I would like to bring it to your notice, that when the electricity is passed, the water must be acidified. Please remember that the water must be acidified. Now, why this water should be acidified? The simple answer is, or the note I would like to bring it to you is this, that pure water do not conduct electricity. Pure water does not conduct electricity. Please remember. So, as the pure water does not conduct electricity, we have to make it slightly acidified so that the water become impure and conduct electricity. Now, my dear students, during these reactions, what happens? We will get the decomposition of water. So let us write the chemical equation for this. Let us write the chemical equation for this reaction. So my dear students, when we write the chemical equation, we would come to know that we just pass electricity to the water. The formula for water is H2O. From this water, we pass electricity. So we have this electricity. When we pass the electricity, my dear students, we get 2H2 and we get O2. Dear students, please mind well that water was in a liquid state, but these two substances that we have got, they are in the gaseous state. Now, my dear students, please understand that, or please remember, even it is very important that this oxygen we get at anode. This hydrogen that we get this hydrogen at cathode. So this is very much important for you to remember this, that these are the various electrodes at which we get these substances. Now, my dear students, this cathode is nothing but your negative electrode and your anode is your positive electrode. Now, if you observe here that we get 2 moles of, or we get 2 molecules of hydrogen, whereas 1 molecule of oxygen. So during this process, the volume of hydrogen, the volume of hydrogen produced is twice the volume of oxygen produced. So this is even an important point, my dear students, that whenever we do the electrical decomposition of water, we get the hydrogen produced, we get the oxygen produced, but the volume of hydrogen produced is double the volume of oxygen produced. So this is how, my dear student, we study about the electrical decomposition. This particular reaction of passing electricity through water is also known as electrolysis of water. Please remember, my dear students, this particular process is also known as the electrolysis of water, dear students. So this is what, my dear students, we study about the electrolysis of water here. And if you do not understand anything, you can ask me, my dear students. अगर आपको इसमें कुछ समझ में नहीं आया तो आप पूछ सकते हैं या फिर हम आगे चलते हैं. Okay, my dear students, let us understand the electrolysis of water. Electrolysis of water. So we will understand this electrolysis of water by drawing a figure. So let us initially, we have one particular mug. We have a mug, my dear students, which is made up of plastic. In this mug, my dear students, we will bore 2 holes. And through these 2 holes, my dear students, we will fix 2 electrodes. So these are the 2 electrodes that we have fixed. These electrodes, my dear students, are passed through a battery and, my dear students, we will put a key over here. If we do not put this battery over here, they can be plugged in. So we can even plug in them. Now, my dear students, here we will fill the water inside it. So we may have the water present inside this mug. When we have this water present inside the mug, my dear students, then my dear students, we are going to put two test tubes. So let us understand how these test tubes are placed inside the mug. So my dear students, we will take two test tubes and then we will put them in the inverted manner above these two electrodes. Please remember, my dear students, that we are going to put these two different test tubes just here in the inverted manner for or above this two electrodes. So now you can see that I am going to draw these test tubes for you, my dear students. You can see this is the test tube 1, this is the test tube 2. Let me make them little bigger so that we can understand it well. So these are the two test tubes that we have. My dear students, then this is the acidified water. And my dear students, when we pass the electricity, these gases which are supposed to be produced, they are bubbled into the test tubes. Now you can see that this is the positive charge and this is the negative charge. Please, my dear students, note that this is the positive charge. So this is your positive electrode. This is your negative electrode. Your positive electrode, my dear students, is known as the anode. At an anode, we get oxygen gas. Your negative electrode is your cathode. And my dear students, at cathode, you get hydrogen gas. And please remember, my dear students, that volume of hydrogen gas is twice the volume of oxygen gas. Volume of hydrogen gas sorry dear students, it's just a problem. I'll just make it correct. Volume of hydrogen gas is twice the volume of oxygen gas. So this is how, my dear students, we truly understand about the electrolysis of water. Please remember, my dear students, that we get the two gases, hydrogen and oxygen, and we get them respectively on cathode and anode. Now, my dear students, we are going to study about the new type of decomposition, which is known as the photochemical decompositions. So let us study about the new type of decomposition, my dear students. So the new type of decomposition, and the new type of decomposition that we are going to study is known as the photochemical decomposition. Photochemical decomposition, dear student. So when it comes to the photochemical decomposition, let us understand this word. What is the meaning of the word photo? Dear students, this word photo means light. So some of the compounds or some of the chemical compounds are light sensitive. Some chemical compounds are photosensitive, my dear students. Photosensitive. Now, what is the meaning of photosensitive? Let us understand the meaning of photosensitive. Photosensitive means when light falls on such compounds, when light falls on such compounds, they are decomposed. When light falls on such compounds, these compounds get decomposed, my dear students. So let us understand these photosensitive compounds with the examples. Examples. What are the examples for the compounds which are known as the photosensitive compounds? The examples of photosensitive compounds are, my dear students, AgBr and AgCl. So dear students, on AgBr or our AgCl, let us take 2 moles of them or 2 molecules of them. Dear students, when light falls on them, you can even write sunlight. So when the light falls on them, my dear students, this AgBr gives 2 atoms of Ag and 1 molecule of Br2. This Br2 is found into the liquid state, whereas Ag in the solid state. AgBr is also solid. Again, my dear students, the same AgCl also decomposes in the presence of light and gives us the solid silver metal and Cl2 gas. So this is the process for the decomposition of the silver bromide and silver chloride in the form of their silver and bromine or silver and chlorine. This particular process is known as the photochemical decomposition. Photochemical decomposition, my dear student. My dear students, nowadays we take the photos with the mobiles, but this AgBr was used to take the photos in the previous time into the camera. So in the camera, my dear students, when we have the roll